Merrill Memo with Matthew Dickerson from Dubbo Regional Council.
Anyway, and it's time for Tech Talk with Matthew Dickerson, and I have him on the line in Studio 2. G'day, Matthew.
G'day, Tony. I'm looking forward to talking about some terrific Tech Talk topics that we can tackle today.
Dear. Anyway, our first topic is something I find quite interesting. Over in Sweden, they're trialling some new technology. It's been around for a while. I'm just wondering how it's going, and that is having EVs or cars driving along roads and charging up as they go along with some technology in the road, wireless charging, no doubt. How's that progressing?
Well, it's interesting. You say wireless charging, no doubt, but there have been a variety of methods that have been trialled, not just in Sweden, but around the world. The concept has been tried in the UK and Germany and Italy and Israel, and Sweden has been really leading the way in this because they believe there's a whole range of solutions here, and I'll get to those in a moment. But they've been trialling three different technologies or methodologies. The first one is a bit like the train system in Sydney, where you've got overhead power lines and then you've got power being able to be provided to a vehicle with that method. Now that means the vehicle's got to have something coming out of the top of it to connect to those overhead power lines. So it's probably more relevant for larger vehicles, maybe trucks, for example, rather than just cars. The second method they've tried is a bit like a slot car. They actually have a slot down the middle of the road, and the vehicle you're driving in drops an arm down into that slot to charge up, just like a slot car has that ability to transfer electricity to a vehicle or a car on a slot track. So that one's been trialled as well. And then the one that you said is the most obvious one, and I agree, is the ground-based inductive charging, just like you would have with your phone charging from a wireless charger. That seems to be the method that's preferred. You install a range of coils underneath the road, and a car needs to be fitted with an inductive receiver underneath the car. And these are already being fitted to cars now because some people put these in their garage and they have the inductive coil on the ground, they have the inductive receiver underneath the car, they drive their car into the garage, no cables need to be connected, and the car charges up in that method. So they've got a 13-mile stretch of highway. They're going to put one of these three methods on, again, most likely the inductive method, so that you'll have this concept. Now, what they really want to do is look at the ability to reduce the battery size in a vehicle because you don't need the same range. The Chalmers University of Technology in Sweden suggests that the battery size may be able to be reduced by about 70%, which means the price of the car can be reduced quite dramatically as well because you don't need that long range. All very exciting. I can see in 10 years' time many roads across, in particular, highly populated areas having wireless charging built in. They call it the Electric Road System, or ERS for short.
Yeah, how interesting is that, Matthew? Now, the next topic is to do with, I guess I would call it smart concrete, because it's concrete with communication using sensors that can basically tell you what's going on as far as the structural strength of the concrete is concerned, and obviously that would help in the construction and also in the long term. It would also help in the long term maintenance of the structures as well.
Yeah, you're exactly right. Now, this is all being done in America. These experiments are being done in America and the testing. One of the things that's interesting is talking specifically about concrete pavements. Now, they only make up about 2% of all US roads, but the interstate system makes up about 20%. Now, generally it's regarded that concrete is more expensive to use in the first place, but gives you a much longer wearing road. So obviously for a long-term project, that's fantastic. But one of the problems they have with concrete is they do a range of experiments in the laboratory. They work out how much concrete might be needed, how long it needs to cure for before you put some weight on there. But the laboratory doesn't always transfer to the real world. So they sometimes find that they put concrete in, they have it curing for the minimum time frame they need to cure it for, and then traffic starts to be used on that road, and they get some failures because it wasn't quite cured properly in some of those locations. So by putting these sensors in, and essentially they drop these sensors in underneath the concrete when it's being laid, not a expensive or complicated process, and then you use a sensor on top of the road to actually check the curing and the hardness of that concrete. Then they know exactly when they can start putting traffic on that particular bit of concrete. So they're already running these trials. Obviously, it's not something you go and retrofit, but if you do need to do some repairs, for example, there was a section of concrete that had failed, when you cut out that section of concrete and relay new concrete in there, you can put these sensors in them, and then you know exactly when you can start to put traffic on there. So you reduce the amount of time that you need for that the concrete to cure, and you also make sure you don't put traffic on until it has fully cured. Getting the right data, the right information, absolutely essential. The researchers believe a lot of money can be saved and a lot of repair work can be saved in the future by using this type of technology.
Okay. Now, another interesting topic. We always have interesting topics, of course, but eVTOLs, or should I say electric vertical takeoff and landing aircraft, or maybe flying cars if you prefer, or airborne taxis, whichever thing you want to call them, they're starting to actually happen now. There's lots of new startups that are developing new, you might say, craft. And over there in America, they're getting very serious because the Biden administration has announced that there's an interagency team formed to establish a national strategy for this very thing. So tell us about that, Matthew.
One of the things that I always find interesting, and we've certainly discussed it before, Tony, is that technology often is way ahead of legislation, way ahead of the laws, way ahead of any strategy for any particular area, country, whatever it might be. And so I actually applaud the Biden administration in this case because they've recognised the fact that we will have some eVTOL, some electric vertical takeoff and landing aircraft out in the skies. They're already testing it in various locations around the world, including in America. But what the Biden administration is trying to do is to get ahead of the technology and make sure they've got a strategy, a framework, if you like, laws in place, a whole range of different things are required. So they've got some of the big hitters in America together. They've got NASA, the Transportation Security Administration, they've got the Federal Aviation Administration and the Federal Communication Commission, and they've put them together and formed a team to say, work out what we need to do to make it effective. Now, one of the things that you might think of is, well, it's pretty easy, isn't it? They take off from somewhere, they land somewhere else. Why do you need a bunch of laws around that? Well, I guarantee once you start seeing these aircraft out there, there will be an accident and people will be injured, people may even die. So getting some sort of framework in place would be important. At the moment, they've talked about using the same routes that helicopters might use, for example. But if I want to take off from my place, Tony, and land at your place and have a cup of tea with you, then I don't want to worry about where the helicopters might go. I want to be able to make it much easier to go from A to B. So do we need minimum heights they need to fly at? Do we need different heights depending on which direction we're flying in? These are all, or just some of the many questions that will be asked to make sure that when we see lots of these in our skies, we'll have very safe transport using eVTOLs. And again, we want to minimise the accident and maximise the convenience.
Yeah, one thing that I always wonder about is, what are you going to do about landing these things? You're going to need space. And the issue of landing and taking off. And then there's parking. So lots to be worked out there, really.
And that's where they've initially said helicopter routes would make sense and even helipads make sense. But again, you're right, that's fine when you've only got a few helicopters up in the air. But when you start getting lots of people buying these for their transportation needs, then you've got to have somewhere to fly them, somewhere to park them, take off, land, a whole range of issues. So that's where I think it's a good idea from the Biden administration to start to look at some of those options and to see what sort of framework they might need first before we start getting the skies inundated with these devices.
Exactly. And we've been listening to Tech Talk with Matthew Dickinson on Binjay 91.5. Thanks very much, Matthew.
My pleasure, Tony. We'll talk again next week.
Merrill Memo with Matthew Dickinson from Dubbo Regional Council.